If you looked around your neighborhood in 2025, you probably noticed something changed. The hum of traffic got a little quieter, and the driveways got a little more plugged in. In the UK, new figures from the industry group SMMT, reported by LBC, show battery electric registrations rose 23.9% year-on-year in 2025, reaching 473,340 cars. That's a 23.4% share of the new car market. It feels like the revolution finally arrived. But there's a question hiding under the shiny paint. What are we actually saving when we switch? Because the environmental story of an EV isn't just the tailpipe, it's the battery supply chain. Mining and refining materials, making cells, shipping parts, and building the car can mean higher upfront emissions than an equivalent petrol car. The payoff depends on how clean the electricity is and how much you drive. So did 2025 mark a genuine climate win? Or did we just move the pollution from the street to the mine, the factory, and the power plant? I'm your host, and today we're separating the marketing from the math. This is EVs, Revolution or Mirage. To help us navigate this minefield of emissions data and economic forecasts, I'm joined by our resident EV analyst. Welcome back to the show.
Great to be here. It's a fascinating time to be looking at this data.
Let's start with the scale of what happened last year. I mentioned the UK numbers in the open, but this wasn't just a British phenomenon, was it?
Not at all. If you zoom out, the IEA's Global EV Outlook 2025 says electric car sales passed 17 million in 2024, more than 20% of global new car sales. And it expected 2025 to push beyond 20 million and move to more than 1/4 of global sales. Just to be clear, in that IEA framing, electric cars means plug-ins, battery electric and plug-in hybrids.
More than 1 in 4 new cars sold globally being plug-ins. Yeah, that starts to feel like a tipping point.
It does, and it didn't happen by accident. Prices came down in key markets, model choices expanded, and policies did a lot of heavy lifting. Emission standards, mandates, and incentives.
Here's the irony I want to dig into. Governments pushed this transition, and now they're staring at the financial side effects. A recent paper in Nature Sustainability flagged what it basically called a fuel tax fiscal cliff.
That's the elephant in the room. Many governments fund roads and public services with fuel duties and excise taxes. That Nature Sustainability analysis estimated global fuel tax revenues at roughly $920 billion in 2023, so on the order of $1 trillion.
And as we stop buying gasoline and diesel, that revenue shrinks.
Exactly. The policy can succeed environmentally and still create a budget hole. Some places are already experimenting with replacements, per-mile road use charges, higher registration fees tied to weight, congestion pricing, tolling, or shifting more of the bill onto general taxation. But there isn't one clean, universal fix yet.
Before we get into the environmental nitty-gritty, I want to touch the day-to-day consumer question, range anxiety. Are we past that, or is it still a thing?
It's better, but it's not gone. A lot of EVs can comfortably handle typical daily driving. The gap is confidence, especially for renters, apartment dwellers, cold climates, and anyone who can't rely on home charging. Real-world range can drop at highway speeds or in winter, and an unreliable charging stop feels different than a quick petrol refill.
And it's not just wealthy countries driving this anymore, right? I keep hearing that emerging markets are moving faster than expected.
That trend is real. The IEA noted that emerging markets in Asia and Latin America saw electric car sales jump by over 60% in 2024 to almost 600,000. In some places, affordable imports and rapid build-out of charging in dense cities help. In others, 2- and 3-wheelers electrify even faster, which matters a lot for urban air quality. I want to circle back to that carbon debt you raised in the intro, because that's where the fiercest debate happens. It's true, producing an EV, especially the battery, is energy and material intensive. On screen, you can see why the supply chain matters. Mines, refineries, factories, and shipping routes are where a big chunk of the upfront footprint lives.
Right. Mining, refining, all of it.
Exactly. But here's a key distinction. A battery electric vehicle has zero tailpipe emissions. That's not a marketing slogan, it's physics.
But the electricity has to come from somewhere. If I'm charging on a coal-heavy grid, am I just driving a coal-powered car?
That's the long tailpipe argument. And the grid mix matters a lot. But life cycle studies generally still find that battery electrics reduce climate pollution overall in most places, because electric drivetrains are efficient and grids tend to get cleaner over time. For example, the ICCT's 2021 Global Life Cycle Comparison found average new BEVs already had substantially lower life cycle emissions than comparable petrol cars. Roughly 2/3 lower in Europe and around 60% or more lower in the United States. In coal-heavier systems, the advantage can be smaller, but it usually isn't zero.
So it's like switching to a healthier diet, but the kitchen matters.
That's a better analogy, yes. And there's another detail people miss. The payback on that upfront manufacturing bump can be quicker than the loudest takes suggest. For example, the ICCT's 2025 EU update estimated battery electrics had higher production emissions, around 40% higher than petrol cars. But those extra emissions were offset after roughly 17,000 kilometers of driving on the projected EU electricity mix.
Okay, so the carbon math can work out. But CO2 isn't the only pollutant. I've heard rumblings about tires. EVs are heavy, right?
They can be heavier, yes, especially larger models. That creates a real trade-off. Regenerative braking generally cuts brake dust emissions, but extra weight can increase tire wear, which adds particulate pollution. And as exhaust gets cleaner, non-exhaust sources like tires, brakes, and road dust become a bigger share of what's left. So EVs help air quality by removing tailpipe NOx and soot. But they don't magically erase all road pollution, especially if the trend is toward bigger, heavier vehicles.
Let's talk about infrastructure. If we're at this 1 in 4 moment globally, do we have the plugs?
Not everywhere. The IEA estimates there were about 3.9 million public charging points worldwide at the end of 2023. And reaching the kind of adoption targets governments talk about would require that number to multiply several times by 2030. And the pain isn't evenly distributed. If you have a driveway, EV ownership is easier. If you live in an apartment complex or drive long rural routes, the charging experience can be the make or break factor.
And what about the cost? EVs have come down, but they're still expensive for a lot of people. We've seen price wars.
The economics are volatile. In the UK, the SMMT has warned that the scale of discounts used to move EVs is unsustainable, and the BBC reported SMMT estimates of roughly £5.5 billion in incentives in 2025, averaging about £11,000 per electric car sold.
Unsustainable for who? Manufacturers?
Mostly manufacturers and dealers. There's a gap between policy ambition and what buyers will pay at current prices. Discounts can bridge that gap for a while, but not forever.
I also see viral claims that subsidies add up to like $50,000 per vehicle. Is that real?
Usually not in the someone hands you 50 grand sense. In the US, for example, the well-known federal consumer tax credit has been up to $7,500, with eligibility rules that often reduce it or exclude models entirely. Some analyses that produce huge per-vehicle numbers are bundling together very different things: consumer credits, manufacturing incentives, local rebates, regulatory credit markets, even infrastructure budgets, and then dividing by sales. That can be a useful critique of policy design, but it's not the same as a direct rebate.
And if the policy props get kicked away,
then you find out which parts of the market were truly self-sustaining and which parts were still being built.
One last thing on the environmental side: recyclability. Are we headed for mountains of toxic battery waste in 20 years?
End-of-life batteries are a real challenge, but they're also a resource. Unlike petrol, which you burn once and it's gone, battery materials can be recovered. Recycling capacity is scaling up, and second life uses, like stationary storage, can stretch value before recycling. The reality is, it's not automatic. It requires policy and infrastructure. But a circular battery supply chain is technically possible.
We've covered a lot of ground, from the fuel tax cliff to the tire dust on our streets. We're recording this at the start of 2026. Looking ahead, what's the forecast this year? Is the boom continuing, or are we hitting the brakes?
2026 looks like a reality check. Some analysts expect growth to continue but slow because incentives and regulations are shifting, interest rates and affordability still matter, and charging rollout is uneven. The story becomes less early adopter hype and more, can this work for the mass market?
So fewer handouts, slower growth, but still growth.
Yes, still growth in many places. In the UK specifically, Drive Electric forecast 580,000 battery electric registrations in 2026, about 29% of new car sales, up from 23.4% in 2025. Still below the UK's headline ZEV mandate target for 2026, but moving upward.
For the environmentally conscious listener who's still on the fence, maybe worried about battery production, what's the bottom line for 2026?
The bottom line is that the direction of the evidence is pretty consistent. Battery electrics tend to cut lifecycle greenhouse gas emissions versus petrol cars, and the advantage grows as grids get cleaner. UK-focused summaries often put today's lifecycle advantage at roughly around 58% lower than petrol equivalents. Peer-reviewed work in Europe can be higher, around 70% lower on the average EU electricity mix. The exact number depends on where you charge and what you're comparing.
So, roughly half or more cleaner over the full life, and in some places, a lot more.
That's the sensible takeaway. And 2026 is also about convenience catching up, more reliable public charging, more transparency on prices, and, at least in North America, continued standardization around the Tesla-style connector, now formalized as SAE J3400. On top of that, bidirectional charging is slowly moving from pilot projects toward real consumer products, using a car to help power a home during outages, or someday to support the grid.
So for the listener driving a 10-year-old sedan right now, wondering if this is the year to switch, what should they do?
Start with your reality. Can you charge at home or reliably near home? That's the biggest quality of life factor. Then check incentives and charging rates where you live. Those change fast. And don't ignore the used market. As more EVs come off leases, used prices can make the math work even when new car prices feel out of reach.
So the revolution isn't a mirage, but it's not magic either. It's a transition with real costs, real physics, and real growing pains.
Exactly. Messy, uneven, and still moving in a cleaner direction.
My thanks to our analyst for walking us through the numbers today. And thank you for listening. If you're charging right now, you're part of the shift. If you're not, maybe 2026 is your year. We'll see you next time.